Hello, Algebra. It's Mr. Zabo. We've got just one real major topic that we want to still discuss with us before we end the school year. And so what we're going to talk about now is simplifying rational expressions. So there's a lot of things that come into play here. We're going to brush the surface of this. We're not going to go in depth as we would have if we were in person. But in the current situation, I think it's really important that you're exposed to this concept and this idea, what it looks like, and then maybe get some brief practice in some of the very basics of it. And then you get into Algebra 2, you'll have to get brushed up on some more of the more intricate details. But really, you have all the skill and ability to do all the intricate details at this point. It's just a matter of not having necessarily the time to practice it that we would have liked. And we'll talk about that throughout the couple videos that we'll send you with regard to this. So a couple things that I want you guys to review real quick first is the idea of simplifying fractions, how you do that. And if it's just a fraction like these, there's nothing wrong with using your calculator if you don't recall how to do that. Look it up. How do you use your TI-84 to simplify a fraction? And it'll help you. You'll find some ways to do that. And then understanding a monomial, binomial, and trinomial. That a monomial is an expression with one term, a binomial has two terms, and a trinomial has three terms. Remembering that terms are separated only by addition and subtraction signs, not multiplication or division. So you could use the space on the right to kind of come up with a few examples of what a monomial, a binomial, or a trinomial might be. Go ahead, press pause, simplify these four fractions, and come up with at least two examples for each of those three types of polynomials. All right, and so here we go. We've got our four fractions up at the top. I've give you three examples of a monomial. I think it's important to understand that all three of those are monomials, even if it's just a constant 3, or just a variable like x, or if it's a combination, a constant, a variable, and an exponent. All of those are still monomials. There's no addition or subtraction. Whereas these are both binomials, these are trinomials, and it's important to recognize that one thing that we did both in Chapter 8 and Chapter 9 spent a lot of time talking about these types of polynomials and factoring them. And that's where we're not going to quite get too deep into this section, into this chapter, but we would have been in person, we would have gotten deep into that factoring once again. All right, before I move on, I want to talk about one additional thing that's super important. And again, we've talked about this a lot, we've reviewed this a lot, and it's the idea of when we're simplifying fractions, why does that simplify? And the concept comes down to the fact that, say if I take 18 over 12 as an example, 18 over 12 actually could be rewritten 18 as 6 times 3 and 12 as 6 times 2. But what is 6 divided by 6? Well, that's 1. We know that. We say that cancels. That 6 over 6 cancels. It doesn't really cancel mathematically. It's equal to 1. When you're dividing something by itself, it's equal to 1. And so that cancels. That's an important concept that we're going to be talking about as we move forward in this video and in this lesson. And here is why. When we're simplifying rational expressions, it's the same as simplifying fractions that are all numerical, except we have these polynomials now. And the concept states that your numerator and denominator must have no common factors other than 1. Just like simplifying fractions. If we go back to that 18 over 12, the factors could have been 2, 3, and 3, 2, 3, and 2. Well, they had these common factors that made us a 6. These are not common factors. So they have no more common factors, and they've simplified by dividing and getting you 1. Okay? But there's going to be a little bit of a trick in this that we have to make sure that we understand. And we're going to get to that in just a few minutes. So let's start by just kind of understanding the concept. If I look at this fraction, I have 2 times the quantity of x minus 1. I have a monomial 2 times a binomial x minus 1. I am dividing it by x minus 1. Even though x minus 1 is not in parentheses, it's still a binomial expression. And what I'm doing here is I have x minus 1 in my numerator and that exact same binomial. It has to match. It has to be a binomial. I'm dividing it by itself. Those cancel. And again, when I say cancel, I don't mean they just go away. They become 1. And when I multiply by 1, that's the identity. It doesn't change anything. I can cancel these or become 1 and give me 2 times 1. This entire expression simplifies to 2. Since both the numerator and denominator have that common factor of x minus 1. Okay? Now, that can happen in the reverse sort of as well, where we have a binomial x plus 3 in the numerator, and then the denominator has a monomial 7, and the same binomial x plus 3. This binomial and this binomial are identical. That means they cancel. But we can say they had a common binomial factor of x plus 3. But where is the 7 located? Okay, you have 2 parts of this fraction, a numerator and denominator. That fraction is located in the denominator. It stays there. This doesn't simplify to 7. Well, what's in the numerator then? Well, remember, we could write that numerator with this parentheses around here, but what number's here? The 1. This entire expression simplifies to 1 over 7. So you always have to be super careful when you're simplifying rational expressions that you put things back where they belong and that you only kind of clean out the factors that can simplify, that cancel each other out. Okay? So be careful what does and what does not simplify though. Because if I look at this, I have an x here and an x here, but this is a binomial x plus 6. That means even though it doesn't have parentheses, that addition sign means these are grouped together. I have to group those guys. So I cannot cancel a monomial x with a binomial x plus 6. Okay? So what cancels here? Nothing. You have no common factors. The only factor is a monomial x in the numerator, a binomial x plus 6 in the denominator. If I asked you to simplify this, it's already simplified. You would just leave it as your final answer. There's no common factors, and we have a monomial x and a binomial x plus 6. It's already simplified. We leave it. So, looking at the example on the right, the first thing that I hope is obvious is they both share common binomial factors. I have 3x squared, and I have x plus 9. Then I have 6x and x plus 9. This is going to be a combination of what we just learned just now and way back in the chapter 7, right at the beginning of second semester. Okay? Because x plus 9 and x plus 9 simplify. But if you think back to chapter 7, if I simplify those, that leaves me with 3x squared over 6x. This is an exponent problem now. Okay? We could write this all out longhand. That's what we did at the beginning of chapter 7, where that was 3 times x, and this was 3 times 2 times x. And we look to see, well, we have 2 3's, that cancels or simplifies. We have 2 x's, that cancels or simplifies. Well, that just leaves a final answer of x over 2. Okay? So once I got rid of the common binomial factors, I could simplify the monomial factors just like we did in chapter 7. Okay? So for the next 2 examples, I'll go through fairly quickly. Common binomial factors of x minus 1 that simplify. That leaves us with a 1 in the numerator. It wasn't written there, but it's still there. 6 in the denominator, and we're done. Okay? Now, what I want you to recognize down here is 3x minus 1 and 3x plus 2 are different binomials. Even though they both have 3x, they do not simplify at all. I cannot simplify those. But I have monomials that can simplify just like we did in chapter 7. Okay? You have x to the 6th power in the numerator, x to the 8th power in the denominator. we subtract our exponents, dividing with the same base, subtract your exponents, and whoever has more wins. The denominator in this case wins, so when I simplify this, my x is going to go with the winner, the denominator. How many points did they win by? Well, they had 8, they had 6, the denominator won by 2. Okay? But the 3x minus 1, I can't get rid of it. And the 3x plus 2, I cannot get rid of it. I can get rid of the parentheses in the numerator if I want, but that's it. That's the last step as far as simplifying this goes. Now, promise you there was one more step, and there is. There's one more important step in this that we want to talk about today before we get some practice. And that's this concept here. When we simplify this, hopefully without a calculator, we can all figure out that this is equal to 2 over 0. Why is that an issue? Okay. I don't hear you, but I think I've got a lot of you saying you can't divide by 0, or, hey, that's undefined, like when we talked about rate of change with slope. And you're right. This is undefined. We can't do this. But that means, since I can't do this, that the denominator in my fraction can never be 0. Well, if I look back here, what if my x was negative 6? Then my denominator would be 0. So we're going to have to state that we have some things that we call excluded values. We are going to simplify this, but state this is always good. This works as long as our x is not equal to whatever values would make the original denominator 0. Okay? So, in other words, a number that would make the original denominator 0. And I emphasize that because even if a term or an expression or a polynomial factors out, if it was in the denominator and it had a variable, I have to count that as far as not allowing that value to let your denominator be 0. What do I mean by that? Well, if we look at this example and I say simplify it, great, it simplifies because my two binomial expressions simplify out and it just gives us 2. But in the original denominator, I had an x minus 1. And based on this idea, that x minus 1 cannot equal 0 because of the denominator cannot equal 0. If I add 1 to both sides here, that means I have to exclude by saying x cannot equal 1. So my answer is 2. This simplifies to 2 as long as x is equal to 1. If x was equal to 1, this is not defined. It is an undefined expression when x is equal to 1. Okay? So back to this second example, and it's the same concept. X plus 3 cancels. We get 1 over 7, but I have to exclude when this x plus 3 is equal to 0. Even though I canceled it out, subtract the 3, x cannot equal negative 3. That's also part of the answer. Okay. I want you to go ahead and press pause and see if you can combine those two ideas that we've talked about very briefly with numbers 1 and 2. Just focus on those two for now. Press pause and try those two, please. For the first one, we get 1 over 10, and x cannot equal negative 4. The second one, we get 3 over 2, because 18 over 12 simplifies to 3 over 2, and you can't have x equal to 3 halves. Now, why don't I say that use the 10? Well, it doesn't have a variable. 10 is not equal to 0. I only have to set things that have variables equal to 0 to find my excluded values. Can there ever be more than one excluded value? Absolutely. And that's why we have examples 3 and 4 here. Simplifying them doesn't change. Even though x plus 2 isn't directly over it, it's multiplication. So it doesn't matter which way we multiply. 2 times 5 is the same as 5 times 2. Those still cancel. We get x minus 3 over x plus 6. Here, x plus 8 cancels, x minus 9 cancels, and the x's cancel. So since we had x plus 2 and x plus 6 in the denominator, I have to solve for both of them possibly being equal to 0. Same thing with number 4, so I can have multiple excluded values.